Hello, welcome back to 8-2 multiplying and dividing rational functions, and in this video we're finally getting to the dividing part. In the last video we did the multiplying, now we're doing the dividing. But before you panic, there's no such thing as division. What? There's no such thing as division. Division is just multiplying by the reciprocal. So again, we'll keep it simple. Let's say your family goes out for pizza. We'll have a round pizza this time instead of a rectangular pan of brownies. And let's say that there's 4 people in your family. All right? So we're going to divide this pizza into 4. So if there were like 12 slices originally, 12 divided by 4, that means you get 3 slices. But that's the same as 1/4 of 12. Dividing by 4 is the same as multiplying by the reciprocal. Dividing by a fraction means multiplying by the reciprocal. Reciprocal. Sorry, my marker seems to be a little fuzzy there. Okay, so I'm going to do these 2 problems in multiple steps because again, I'm making a video, I'm explaining. All right. In the next one, the next 2 problems in the same video, I'm going to combine one of the steps, but I don't want to lead with that because it's going to save me time, it's going to save you time, but it's also going to look a little confusing. So I'm going to do the whole thing here. All right. So the first thing I'm going to do is I'm going to multiply by the reciprocal. Okay, and please, if your elementary teacher ever used keep, change, flip, I want you to just delete that from your brain, okay? That's a horrible way of doing it. Keep, change, flip. Ugh. You are multiplying by the reciprocal. We are mathematicians. Anyway, so this becomes 4, I don't think this marker is much better, 4x cubed over 9x squared y. So that one does not change. Division is not a commutative operation, which means I can't just turn it around. 12 divided by 3 does not equal 3 divided by 12. I can't turn it around. What you are dividing by, I'm dividing by this. This is going to become, I'll use a dot for dividing. And I'm going to change this, flip. 9y to the 5th power over 16. Okay, I need to say one thing too, by the way, before I forget it. This thing right here, this is called an obelisk. I believe it's spelled that way. There's a governing body that sets the parameters for how mathematicians, engineers, scientists describe things. Okay, for example, this symbol right here, the Greek letter delta, means change. And all scientists and engineers and mathematicians, we know that. Okay? That's what we've agreed. So there's not going to be like some random dude at, like Stanford who says, I think we should use an epsilon. Epsilon means something else, okay? So we're all communicating the same thing. And that organization has the international system, I forget the name of it, I'll have to look it up, but that organization has decided, and good for them because I've been saying this for years, that we're going to avoid using the obelisk. So if you heard me say before, don't use this, you're probably wondering why it's showing up. The reason why is because if let's see what I did here, I didn't write 12 divided by 4 like that. I wrote it as a fraction. Well, when I got fractions divided by fractions, then I got fractions in fractions. I got fraction inception. That's fine. It just looks really nervous looking the first time you see it. So we're going to go with the obelisk for now. But again, we want to make sure that we avoid it for future. There, I said it. Okay, this looks just like we did in the last video. I get 4x times x times x times 9. Oops, excuse me, I should have said 2 times 2. I did that again. 2 times 2 times x times x times x. I'm sorry about that. times 3 times 3 times y times y times y times y times y. Woo! Divided by, excuse me, got hiccups. 9 is 3 times 3. Those are going to match up with those. X squared is x times x. Here's another y. And of course 16 is 2 times 2 times 2 times 2. So these 2's are going to go away. These 3's are going to go away. I think I got all that taken care of. Let's look at the x's. These x's are going to go away. And the only thing I have left here is a y, so that's going to go away. So in the numerator, I get x, 1, 2, 3, 4, x times y to the 4th power. And the denominator, I just get 4. Now, again, this is expanded form of exponent rules. We're using the quotient property. All right. You can actually, to multiply, I would use the product property. 3 plus, oh, so those are not the same, excuse me. So I guess I wouldn't have to. Okay, so I do 3 subtract 2, which gives me my 1, and 5 subtract 1, which gives me my 4, my y to the 4th. So I'm using the quotient property. But I'm just doing this because, like I said, I'm in teacher explain mode. For this one, first thing I'm going to do is I'm going to leave x squared divided by 4 alone. Then I'm going to multiply the 12y to the 2nd power. I'm going to move to the numerator. And the x to the 4th y, I'm going to move to the denominator. And again, I'm just going to expand it real quick because I'm just self-conscious of the fact that if I say, and by the way, this equals that, I always have someone who says, oh my God, where'd that come from? So this is x times 12 is 2 times 2 times 3 times y times y. 4 is 2 times 2. X to the 4th is x times x times x times x times y. So I'll get rid of those y's since they're over there. I'll get rid of these 2's, and I got a couple x's. I think that's it. So I get 3y over x to the 2nd power. Please note that we've mentioned all expressions are defined, which means I don't have to figure out what's going to make the the denominator go to 0. Okay, these are fun, but this right here is what we're really heading toward. All right, now, go back to this. I first found the reciprocal, then I factored, I canceled common factors, and then I remultiplied what I could. So instead of all these y's, I wrote y to the 4th power. So again, I factored, I canceled, reduced, simplified, whatever you want to call it, and then I remultiplied. Before I did that, I took care of the reciprocal. I'm going to do 2 things at the same time for this video. And if it bugs you, please ask questions in the discussion, but I think everyone's going to be okay with this. I'm going to factor, but when I write these factors, whatever 4x squared minus 1 is, I'm going to put it in the denominator. And when I factor this one, I'm going to put it in the numerator. So I'm going to write the reciprocal when I factor it. Okay. However, I'm trying to find some, I'm still here, hang on. Just couldn't reach for a piece of extra paper. This first problem, this is probably the hardest it's going to be. And not hard. It's probably going to be the most steps. So all I'm going to do is I'm just going to grab another sheet of paper so that I can do some of the factoring off to the side, because I've got some diamond method factoring. All right, so let's look at it, and hopefully it won't bleed through. It's still there. I'm going to write it. I can see it. I know you can't. But this is 2x squared subtract 7x subtract 4. All right, if you don't know how to factor this, please watch the 8-4 videos from Algebra 1. 2 times negative 4 is negative 8. Negative 7 goes here. What multiplies to give negative 8, but adds to give negative 7? That's negative 8 and positive 1. My multiplication chart has 2x squared subtract 8x, 1x, and negative 4. Factor across the top, I get 2x. That leaves the other x. That leaves negative 4. Factor across the bottom, I just have 1. So this is going to factor into 2x plus 1 times x subtract 4. This is Algebra 1 stuff. That's why I'm doing it fast. X squared subtract 9, that's the difference of two squares. That just becomes x plus 3 times x subtract 3. 4x squared subtract 1, that is also the difference of two squares. 4x squared subtract 1 becomes 2x plus 1 times 2x subtract 1. And again, you need to watch or Google, I don't care, difference of two squares. Finally, I got this last one. 8x squared subtract 28x, this marker's almost dead, plus 12. Okay, first thing I notice is even, all of these have a common factor. It's definitely 2, it might be more. This is 4 times 2, this is 4 times 7, this is 4 times 3. So I have a common factor of 4. That leaves 2x squared subtract 7x plus 3. Okay, so the GCF was 4. That makes the rest of this a lot easier. Now I'm going to factor this one using my diamond. 2 times 3 is 6. What multiplies to give 6? Positive 6 adds to give negative 7. That's negative 6 and negative 1. 2x squared, negative 6x, negative x, and 3. This will be 2x, the other x, negative 3. And this is where I'm going to factor out my negative 1 to make it work. So, in factored form, this is 4 times 2x minus 1 times x subtract 3. You know how to do this, you know how to do this, you know how to do this. It's just factoring. So now let's go back. And I know you can't see my other sheet, but I'm looking at it. I'm going to show you what you need to know from it, okay? For the first rational expression, 2x squared subtract 7x minus 4 was this. 2x plus 1, x minus 4. The x squared subtract 9, that's my x plus 3 times x subtract 3. And by the way, I haven't said it yet, it doesn't matter. The order doesn't matter. If you write minus 3 here, plus 3 here, that doesn't matter, okay? Now, watch what I'm going to do. I already got these factors here. When I write them, I'm going to also make the reciprocal. So 4x squared subtract 1 is 2x plus 1, 2x minus 1. But I'm going to go from the top to the bottom. And the 8x squared minus 28x plus 12, which is here, I ended up with 4 times 2x minus 1. Maybe you can still see it. 4 times 2x subtract 1 times x subtract 3. Draw that out a little bit more. I have all these Sharpies, and they're all getting dry on me. I don't know why. Okay, so I factored and did the reciprocal at the same time. I'll draw some arrows in here so you can see it, like that. So I did it at the same time just to save time. Now I need to start canceling stuff out. And if I was in my classroom, what I would do now after everyone had written it in their notes, I actually kind of just go through, I use my, I got like a little dry board eraser, and I just start wiping things out. Well, I can't do that here. So here's what I'm going to do. 2x plus 1, x subtract 4, times 4, times 2x subtract 1, times x subtract 3. I'm going to start crossing things out, but I'm rewriting it just so that you can see what the original was. That's the only reason. So 2x plus 1, here's 1. Those go away. Here's x subtract 4. I don't see that in the bottom anywhere. Here's 4. I don't see anything in the denominator. It's going to reduce with that. Here's 2x minus 1. There's 2x minus 1. Those are going to go away. And it looks like the x minus 3's are going to go away. So what's left? 4 times x minus 4. And I usually put it in the front. I don't really care. And what's left in the denominator? X plus 3. And that's it. It's a lot of work, but absolutely none of it is hard. Okay. Same thing with this one. I'm going to try to do the same thing here. I'll split screen it the old way. I got x to the 5th subtract 4x squared. So it looks like I got x to the 5th. I'll write subtract 4x cubed. I have a common factor. X cubed. I'll leave it x cubed instead of x times x times x. X squared minus 4. That's the difference of two squares. So I get x cubed times x plus 2 times x minus 2. Excuse me. X squared subtract x subtract 2. What two numbers multiply to give negative 2 but add to give negative 1? That's going to be x subtract 2 times x plus 1. All right. X to the 5th subtract x to the 4th subtract 2x cubed. That has a common factor of x. I should work. Let's be consistent. That has a common factor of x to the 3rd power, which leaves x squared subtract x subtract 2, which actually is that one. I've already done that before. That's going to be x subtract 2 times x plus 1, but don't forget the x cubed. And this one, x squared minus 1, that's the difference of two squares, x plus 1 times x minus 1. Okay, so now I've got all of my numerators and denominators factored. I'll keep that off to the side. I'm going to rewrite this. Hopefully I got enough room. I got x to the 3rd times x plus 2 times x subtract 2. And, oh, sorry. Put the times there, sorry. And this one was x subtract 2 times x plus 1. Okay, now, the numerator here, factored right here, x cubed, x minus 2, x plus 1. But I'm also going to change this dividing, into multiplying, so I'm going to put it in the denominator. So I get x to the 3rd power times x subtract 2 times x plus 1. And x squared minus 1, that's x plus 1, x subtract 1. But of course, I did these two. I wrote it as reciprocal when I rewrote it with a factor. Okay, so I'm not going to recopy this one. Here's x cubed, x cubed. Those go away. X plus 2, I don't see an x plus 2 down here. X minus 2, yep. Could have been that one either, that's fine. X plus 1, those definitely go away. And x minus 1, I don't see any more x minus 1s down here. The x subtract 1, x plus 1, those are not the same. The x plus 2 and x minus 2, those are not the same. So if I rewrite it, I do x plus 2 times x subtract 1 divided by x subtract 2 times x plus 1. And you can leave it just like that. If we were actually in class, we would go back and remultiply these to put them in standard form, but I don't think we need to for right now. Okay, see you in the next video.